Hey there, I just want to make a quick video for you to go over some essential algebra vocabulary. Now, I know that in math we don't often think about vocabulary as being an important part of math, and you may have heard a lot of these definitions like said to you at some point in a class somewhere, or maybe even multiple times, but I'm a big believer that you don't realize how much this vocabulary matters. A lot of these words I'm going to go over, you've heard them before, you might think that you understand them, but I'll bet if I was to ask you a definition for these words, you maybe couldn't come up with one. And that becomes a problem when you're in a lecture, you're trying to pay attention, and you go, wow, they just said a bunch of words and somehow I got none of it. That's a vocabulary problem. Or you read a problem to do on a test or in a textbook, you go, man, for some reason I'm just not picking it up. These math people, they talk weird. That's a vocabulary problem. So I'm going to go over all this essential algebra vocabulary in preparation for my next video, which is going to be about factoring. But in factoring, we use a ton of vocabulary, and so I want to make sure that you're on board with it. All right, so here we go. The first word I want to talk about is expression. So what is a mathematical expression? The way I'm going to talk about expression with you is I'm just going to give you a bunch of examples, okay? So for example, negative 2x squared, that's an expression. X plus 3, that's an expression. Let's see, x squared plus 3x minus 2, that's an expression. An expression is essentially a combination of numbers and variables and operations. They can be added up together. They can multiply things together. That's an expression. Okay, so that's the first thing I want to talk about. This idea of having an expression. The next thing I want to talk about is an equation. Okay, an equation. An equation is a statement about the world. It claims that two expressions are equal to each other, okay? So for example, I could say that the expression x plus 3 is equal to 0. 0 can be an expression too. And so I'm claiming that these two expressions are equal to each other. And this expression, this equation rather, that claims that these two expressions are equal to each other, it has a value of x for which it's true. If x was equal to negative 3, then this equation would be true, right? But that's not always true of all equations. For example, I could have an equation 3 equals 2. That's the equation. It claims that two expressions are equal to each other. It's just a false equation. It's an equation that's not true. It's a statement about the world that claims that 3 is equal to 2, but 3 is not equal to 2. Does that make sense? It could be false. That's fine. Now, let me show you another equation. X squared equals 9. This equation, for example, has two values of x that make it true. Both 3 and negative 3 make this equation a true equation, and it satisfies this equation. When we have a value of x or a value of a set of variables that make an equation true, that make it so that one side of the expression, one expression really is equal to the other, then we say it satisfies the equation, okay? So I've talked a little about expressions, talked a little about equations. I just want those to be really comfortable mathematical vocabulary for you. Now, terms. Let's talk about terms. If we look at this expression that I had wrote up earlier, x squared plus 3x minus 2, that expression has 3 terms. 1, 2, 3. Okay? So those are terms. Terms are things that are added or subtracted, okay, from each other. The groups of things which are multiplied together that are added or subtracted from each other. For example, let me just show you. This is x times x. Those things are multiplied together, and they form one term, and then we add that to the term 3 times x. Those things are multiplied together. And then we can even say we add this to the term -2, okay? So terms are summed up. They're added together, okay? We have 3 in this expression. If we were to take this expression x plus 3 that we've talked about, that has 2 terms. Something that's really important about terms that I want you to know is it includes the sign, like this -2. The negative was included in the term. Okay, so if I had another, let's say I'm going to give you another expression, and you can tell me how many terms it has. So suppose I had like, I don't know, let's see, -4 xy plus 2 x squared minus 3y plus 4. How many terms does this have? 4. We've got this -4xy, this positive 2x squared, this -3y, and this 4, okay? Now, like I was saying before, remember that the negatives are included in the term. So this whole thing, -4xy, is the term, okay? And terms of these things are summed up. That's how I want you to think of them. Okay, so we talked about expressions, equations, and terms. Being really familiar with these is going to make everything easier. So now I want to make sure you're really familiar with factor. What is a factor as a noun? What is a factor? If we take, let's take this term that I mentioned up here, -4xy. We can imagine that, -4xy, this is a bunch of things that are all multiplied together. I can even break out the negative if I want to say. It's a -1 multiplied by a 4, multiplied by an x, multiplied by a y, okay? These are factors of that term, okay? In fact, I could even go a little bit further if I wanted to. Those are definitely factors of that term, but I could even break up that 4 if I wanted to. These are factors. Factors are things that end up multiplying together, factors, okay? So if you take a thing and you break it up into you divide it into parts, and those parts, they multiply together to make another thing, those are factors, okay? So these are factors of this term, -4xy. We can do the same thing even just with like a constant. Like let's say we took the number 12. Okay? I say it's a constant because it's not a variable, because it doesn't have a variable like x or y in it. And so we can say, what are the factors of 12? Well, 12 has all kinds of factors. 12, I could say, well, 12 is 1 times 6. So 1 and 6 are both factors of 12. Sorry. 2 times 6. 2 and 6 are both factors of 12. Or, let's see, 3 times 4. 3 and 4 are both factors of 12. Another thing I can do is I can talk about the prime factors of 12. Remember, a prime number is a number that is only divisible by itself and 1. Right? It can't be divided by any other numbers. So the primes, and let's just go through them really quick. That's a good vocabulary word. I'm going to go ahead and add it. Prime, okay? A number that can be divided by only itself and 1. And I'm just going to give you a list of primes. You're probably pretty familiar with them. 2, 3, 5, 7, let's see, 11, 13, 17, and there's a bunch more. In fact, there's an infinite number of primes, okay? But if we were to break 12 up into its prime factors, which, by the way, is processed with, it's a prime factorization of 12, okay? Here's how we do that. Here's my favorite method anyway. We'd say, okay, well, 12 is 2 times 6, and 2 is prime. So when I find a prime, I'll circle it. And then 6 is 2 times 3, and those are both prime, so I'll both circle them. And then when all these circles are there and there's nothing else to break up, I call them leaves. When all the leaves are prime, then you stop. And so 12, its prime factorization is 2 times 2 times 3. Now, being familiar with the idea of prime numbers, the idea of factors, the idea of terms and expressions and equations, and being really comfortable with those words is going to make learning math a whole lot easier, I promise. And what's really cool about that is you just memorize the definitions of these things, and all of a sudden it gets a lot easier. So that's pretty cool. Okay, so let's see, we've gone through expressions, equations, terms, factors, primes. Let's see, coefficients. So, we also talked a little bit about variables. I'm going to leave that for a later time. But what I really want to talk about now is coefficients. Coefficient. So if we take that same term that we've been working with a little bit before, oops, which was negative 4xy, it's got these variables in the term, x times y, but it's also got this number out front, negative 4, okay? The bit that's not a variable, the bit that's just the number out front, that's the coefficient, okay? So let's see. So this is the coefficient of the term negative 4xy. If we take some other thing, let's say, here, I'll take this whole thing. Negative 4xy, negative 4xy plus, what did I say, 2x squared, oops, plus 2x squared minus 3y plus 4, minus 3y plus 4. If we look at that, we can identify a coefficient for each of these terms. It would be negative 4, 2, negative 3, and I think we'd even say that the coefficient of this term is 4. So it's just the bit of a term that is a constant number and not a variable, okay? That word coefficient is going to get thrown around, especially when in my next video when I talk about factoring. And so I don't want it to be like, oh, what was that? What are coefficients? I don't quite remember. I want you to go, oh yeah, that's that number part in front of the variable. I don't want it to be a cause of any confusion later down the road. So, okay, now, after all that, okay, just remember, expressions, equations, terms, factors, primes, coefficients. Now, polynomials. Polynomial. I think it helps, in order to remember what polynomials are, to look at the roots of this word. Poly means many, and nome means name or term, okay? And so polynomial essentially means many terms. It's a thing with many terms. This thing that I drew up here, that's actually a polynomial. It's got many terms. It's got 4 terms, okay? Classic polynomial, let's see. X cubed plus 2x squared minus x plus 1. Okay, it's got these 4 terms. It's got many terms. It's a polynomial, okay? So that's a polynomial. Let's see. A binomial. Pretty similar, okay? Binomial, let's look into it. Bi, meaning 2, and nomial, meaning, terms. So this is 2 terms, Okay, binomial. Okay, classic example would be something like, let's say, the x plus 3 that we had talked about earlier. Okay, x plus 3, or 2x minus 7. And they don't have to be just like that. They could be, 3x squared y minus 7y. That could be, it's a binomial. It's two terms, okay? All right, polynomial, many terms, binomial, two terms. Got it. Let's see, what's next here? Quadratic. 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 Now, quadratic is specifically where I'm going to use another term here I haven't introduced to you yet, hopefully, but I'll tell you what it is. Where the degree of the polynomial is 2, where it's a second degree polynomial. So let me explain that word degree since I hadn't talked about it before. I want you to notice that this polynomial I gave you up here, the highest power of x in that polynomial was 3. So we would call that a third degree polynomial, okay? Up here, let's see, in this is also a polynomial, got many terms, and the highest power of x here is 2, that's a second degree polynomial. So you get what degree is, hopefully. So a quadratic is specifically a second degree polynomial. So for example, x squared plus 4x plus 4. Okay, that's a quadratic expression, okay? If I were to say x squared plus 4x plus 4 equals 0, then that's a quadratic equation, right? Okay, cool. So quadratic, though, just means that the degree, or the highest power of x, is 2, exactly 2, not 1 or 3, okay? Quadratic, perfect. Now, let's see, expansion, let's talk about it. So here's the deal. Let's say you have a couple binomials. Expansion. Let's say you have the binomial x plus 1, and you have the binomial x plus 2. And these are going to get multiplied together. So by the way, in algebra, when things are set next to each other, it often just means that we're going to multiply them together. So these two binomials, we're going to multiply them together. And you may recall that if I have, say 2 multiplied by the binomial x plus 1, that the 2 needs to distribute through there. It needs to go to each thing inside that group. The 2 is getting multiplied by the group x plus 1. And so in order for that to happen, both the x and the 1 need to get multiplied by 2. Hopefully that makes sense. So for expansion, what we do is, instead of writing it as these separate binomial factors, we multiply everything out together. And so we say, okay, I'm going to distribute this group through that group. You may recall this acronym FOIL, first, outside, inside, last, and that might help you with this. We could talk about this in another video too, but firsts, outside, that'd be 2x, inside, x, last, it's 2. I can combine these like terms, so it's x squared plus 3x plus 2. Hey, if that was fast and you'd like a video about that, let me know in the comments. So the process of taking these factors here, okay, and going to a form like this, that's expansion. And since these things that we expanded were binomials, we would call this binomial expansion. Awesome. Now, let's say we did a different kind of thing. Okay, that was expansion. Let's say we wanted to factor, and this is factor. We talked about factors before, what they were, the noun factor. But this is the verb factor that I want to talk about. So what does it mean to factor as a verb? So let's take, for example, that x squared plus 4x plus 4 quadratic polynomial that I had mentioned up there earlier. And let's say that we wanted to write that as a couple of different binomial factors, okay? Which, by the way, the details of this are going to be in the video that I post tomorrow. So I'm not going to go into too much detail here. But I can write this as a couple of factors. And if we were to FOIL these factors back out or expand these binomial factors back out, we would see that we end up with the same thing. You know, for example, I say go first, outside, inside, last, firsts, outside, inside, last, and I end up once again with the same quadratic expression that I started with, okay? All right, so I'm pretty sure I hit up all of the vocabulary that I really wanted you to have. I'm telling you, if you're really comfortable with this vocabulary, it's gonna make learning math a whole lot easier for you. When you read a problem on a test, when you read a problem in the textbook, when you're listening to your teacher talk up there, it'll all seem like it makes a lot more sense. And it's just memorizing some words. So I hope that you watch this video and you get really comfortable with these words. I'm going to use them all in our discussion about factoring tomorrow. Okay, I hope you have a really good day. Talk to you soon. See ya.